Hey, Kool-aid Krew, somebody give me a 5 for 5 and we'll get going. As I get going here, check this out, guys. This is the Comet that we've been talking about. Comet Atlas, whatever number that is. But check this out. This is from LASCO C2. It's a satellite, sits right out in front of Earth, and it's from our point of view. This was almost a naked eye daytime comet. So, and it's out by the sun. So close, and we'll dive in. I actually got a different view of this too from a different satellite, stereo A right here. Check this out. Look at this thing. So we're gonna get to see the CME hit this thing and Earth. The CME is moving over 2 million miles per hour, and it did get into G5 levels for a brief moment so far. Could get there again, but we're gonna take a look at that. So. Here is our magnetosphere. This is what conditions at Earth right now. This is speed. Sun is off to the left. Check this out. You can see the waves just coming in, just blasting and blasting. The darker reds are the higher speed. The darker blues are moving the same speed, but they are actually moving the opposite direction. So it's all done by polarity, negative and positive. So when we have blue, it's actually moving right to left. Now, how can it do that going against the sun? Because this is sitting inside of our magnetic field, our magnetopause. Okay? So it has the protection of Earth's magnetic field. So things inside that, the conditions are different. All right? Without that, guess what Earth becomes? Mars. Okay? This is density. The darker blues, higher dense. So, yeah. You can definitely see that. Very high dense stuff going on there. Hey, Renee. Change the window. Crap. Did I not do that? Alright, we'll get back to it then. We'll have to go over that again. I do that a lot. I need to just not even show my logo there. I'm just going to start off with this from now on. Sorry about that, guys. I apologize. Another rookie mistake. Anyway, okay. So, look, guys. This is the 30-minute index. HP. We measure geomagnetic storming by the KP. It's just an indice that they've created for geomagnetic activity. Okay, this is the KP. These are 3-hour averages. This is 30 minutes, so it's more real time. Guys, this thing got over a 10. A 9 is the beginning levels of a G5. So we've seen the same thing back in May, when we had the G5 storm back then. This eruption on the sun got here in just over a day. It's moving at 2 million miles per hour, guys. It's fast. Plus, check it out. We had other eruptions after. This is the eruption that sent the CME our way. But we've also have flaring, X-flare there, almost X-flare. We've had a couple longer duration M flares, significant ones, that have fired other CMEs also. This is radiation. I haven't been able to show you guys a radiation storm at an S3 level very often. I think this might be the second time, for me anyway. Now that's measured by protons. Those get here in like 20 minutes to an hour when we get a big shot from the sun. Typically, from shots like that, it will take the CME involved with that about a day, day and a half, 2 days, even 3 days. It can still hit us really hard. The average time is right around 3 days. But CMEs can get here in 2 to 5. That's the threshold we use. But this is that comet that I tried to show you a minute ago. And yeah, there you have it. So this is a satellite right out in front of Earth called SOHO. And we're able to see the comet. Comet Atlas. Actually, let's just show you the name of it here. This is Dr. Tony Phillips' page right here. This is spaceweather.com. So yeah. Now, look at this. Yeah, he's even saying G5 now. Okay? So come over here and give him some love. Alright? Please do it. It would be so cool if you did. He deserves the traffic. Everybody in this community comes here. This is one of the go-to websites that we go to see and really kind of check ourselves sometimes on what we're reporting on. Dr. Tony Phillips is awesome. Plus, guys, please go check out Dr. Tabitha Scove. You would be doing yourself a disservice if you didn't. She uses things like slinkies to explain space weather. So even though there's a bunch of word salad, she brings it down to a level that all of us can understand it. It's Dr. Tabitha Scove. Go check out her channel. She's getting pretty big. She's been on the Weather Channel and stuff like that. I've had a few small conversations with her, you know, in a comment section. I think I had a conversation with her over on her X page before, but not very many. But it's just awesome stuff, guys. She knows what she's talking about. If I had to pick one person in the community, that's exactly who I would go to first, just so you know. So let's go back here to the 9th, and let me show you this here real quick. I just want to get the name. I can't say it. Right here's the comet name. Okay. Now remember, yesterday it passed over, basically was in a direct horizontal line with us and the sun. So you could draw a straight line from us to the sun. The comet would have passed right through that line. All right. Or at least on that same plane. Not necessarily right in front of us, but it was on the same plane. Why is that important? Because what happens is the dust from the comet, the sunlight will actually hit that dust, and we get what's called forward scattering. It scatters the light from the sun off of the dust particles of the comet, and it makes the comet brighter from our vantage point. So they were talking about this could have been a naked eye daylight or daytime comet, and it barely missed. Gosh, it was so close. They're talking about it right here. They measure that by, let me see, let me get to the thing here before I get too far. But also passing close to the sun. Maybe it was the next day that he talked about this. It might have been here on the 10th. Let's take a look here. Okay. Oh, okay. Let's see here. Peak voltage in the U.S. Midwest. He's talking about the geoelectric field here, though. But in a vantage point here, he puts it in perspective for you here. We had the Great Quebec Blackout back in 1989. This is about 25% of what caused the Great Quebec Blackout. So that's the level of stuff we're talking about here. Most of us remember that were alive back then. It was a big deal. Okay, we had the solar storm, Halloween solar storm of 2003. Everybody understands that the Carrington event back in 1859, that's really where space weather became space weather. You know, at least modern day space weather. That's when we were able, or Dr. Carrington was able to figure out that a flare was different than a CME. A flare is nothing more than an X-ray, and the CME are charged particles from the eruption. Well, I see we got some more stuff in here already. Who donating now? Let me see. What we got? What we got? What we got? Let me go back up here. Looks like Planet Hermit for 5. Yeah, Planet Hermit right there for 5. Gifted memberships. Thanks again, once again, for supporting so much. And Aaron, same thing. And Heidi did it right before we went live. So that's 15 for today. Guys, we're getting real close to 500 members. That's really, really cool. Really, really cool. But please share this out, guys. Hey, Genius, good to see you. Daryl, good to see you. Face of the Moon, what's up, Miss V? Miss V and Izzy. Okay. Now, so let me just get into what we're talking about just a little bit deeper here. I wanted to make sure you guys seen that comment because it's important, and we're gonna dive into this a little bit more too. This is Stereo A, guys. This is the one that used to be out by 90 degrees to the sun, right? But now it's hanging out right around Earth. It's outlived its lifespan. Most people won't even show you these images anymore. This is a SETI tool on this imager, on this satellite, okay? So what you're looking at here is, I think it's HI1, yeah, HI1. And so that line there that's just an artifact of the camera. Okay, that's Earth. This is the comet. They don't always appear to be this bright. Now you're going to see the CME pop on here real quick. You can kind of see it. Now we don't have any more data past this, unfortunately, but we're going to get some. So when we get there and I can show you a full run of this, I will. Okay, it'll probably be tomorrow or the next day. But I wanted to make sure I showed you guys that. I've showed you guys this before. There's actually other imaging we can look at also here. Let's look at this real quick and see what it'll do for us. Let's just hit search. Yeah, so here's another view. Same kind of thing, same tool, but it's a different kind of imager. So you kind of see the CME a little bit better there. You see how dense that got real quick? Now I can show you this other one, and I'm going to say something before I hit go on this one. You're going to see like a ghosting, and I'll show you what I mean. Okay, that one's not. That one there usually have to have 3 days behind you. It's a 3-day lag. So here's HI2, and again, once again, you know, there you go. It's kind of hard to look at this and explain it to you guys without being able to go into a deep explanation on the perspective of how this thing is working. And I'm not going to do that tonight. It's just simply not needed tonight. So, but that is another image that you could look at. But yeah, so we could go into other places. So this is what I mean when I tell people, hey, the data is not missing. The data is there. You just got to know where to go look. So just because you couldn't see some of the data on other places, like on, and this happens a lot, and I'll explain to you here in just a second. But we'll dig into that in a minute. But I do want to show you guys this. This is the Australian magnetopause model, and we're going to look at it today as it hits. Now I'm going to pause it here because we get all the the pertinent data that we need. Solar wind speed, proton density. There's your BZ. Okay, we need -6, so we're in a magnetic polarity position to be able to couple with this magnetic fields inside the CME. When that happens, when we're at -6 or more, we really couple to most of the geomagnetic or the magnetic fields inside the CME. So when that happens, like I said, guys, we get hit harder. Now the standoff distance is nothing more than the bow shock position. Okay, the bow shock is the first point of contact between space weather and our magnetic field. Sorry about that. I was distracted there for a second. But anyway, you got that going on right there. I'll play that here. Matter of fact, I'll play it here. And, well, let me back it up to the 10th there. Thank you, Genius, for the gifted memberships. She hit us with 5 there, too. That makes 20 for tonight. Awesome stuff. Thank you so much. Appreciate you. I definitely will stop in here in a little bit, and we'll give you guys a proper thanks. But as you can see, our first point of contact, guys, look what's happening. Right? It's like a tuning fork. Now, there's going to be something here that I'm going to be able to show you that I haven't been able to show you very often. This is the satellite line. Okay, so when our bow shock gets inside the satellite line, anything on the left side of the bow shock is exposed to direct space weather. No magnetic protection from our magnetic field whatsoever. Okay? So that's important because without that magnetic protection, like I said earlier, we become Mars. So what do you think it's going to do to satellites that are out there just all the time? Now, yes, they can build them in certain ways. Sometimes they'll shut down into safety mode. We see that a lot, especially during bigger solar storms. But I want to show you guys this right here. Check this out. You see this number? That's -37 on the BZ. What do we need to couple with it? -6. That is a big negative number. Okay? So things are coming together for us to really take a real hard hit here, and we are. So I just wanted to make sure I pointed that out. Now, once again, let's just take it back to the 10th here. I'm going to try to pause it so you guys can see. But this is what our bow shock does. Our bow shock gets compressed, and then we get rapid expansion. Compression, expansion. It's a constant thing during these storms. Okay? So I'm going to pause it right there. You see how close it got there? Now if I back it up, it actually got inside the line right there. See that? Or at least right on the line. Now remember, when this thing is getting compressed, what's it doing? It's compressing all of our magnetic field lines in the front. So it's putting a ton of magnetic pressure on us. What does that do? Well, sometimes some of these field lines will break. They'll break wherever they break at, and they'll peel back on both sides of us, and they'll reconnect back here. When they reconnect, if our magnetotail is stretched out enough and it reconnects in the right point, we'll get an Aurora substorm. When those things reconnect, it'll give us global Aurora for a short period of time, just right around where it comes in. Okay, I'm not saying you get it everywhere. What I'm saying is, on that latitude line, North Pole, South Pole, whatever latitude line it comes in at, that's what you'll see. You'll see it globally. Now, obviously, you're not going to see too much during the day. So, but it would be there if it was dark. Okay? That's the best way to explain it, I think. All right, so if I take you back here to, this is our geoelectric field. What is this? This is space weather's effect on unnatural electrical components. What is that? Well, anything not made by nature. Wall switches, wires, batteries, car batteries, transformers, substations. Okay? So what they've done is they put together this model. Canada was just added to this about a year ago. Why are they doing this? Well, they're using it to help forecast earthquakes. Now, we know space weather has a direct effect on seismic activity. Okay, we always get an uptick, whether it's in intensity or frequency. We always get an uptick. Now, they're using this as one of the data points to look at, right? So they can actually forecast it better. And what they're trying to do, obviously, is try to give everybody as much warning as they possibly can during any kind of earthquake. So that's the purpose of this. Now, just as much as the magnetic conditions affect this geoelectric, the opposite can be true too. Okay? But most of the time we're getting hit with stuff from the sun, and it affects the geoelectric as geomagnetism is in the area. Okay? So that's kind of happening. If you guys don't know what the global electric circuit is, you probably need to go Google that. I'm not going to go over that tonight, but that's one of the key things that we look at. But also, let's see here. I do want to show you guys, what did I do with that? I know I had the magnetopause tools pulled up. I know I did. Well, let me pull them up again. Sorry, guys. I thought I had them there. My bad. All right. Let's find them right here. Now, so what you're seeing here, like I showed you guys, or attempted to earlier, again, this is our magnetopause. This is Earth's protection from the sun, our magnetic field. And what happens is when stuff from the sun or space weather hits our magnetic field, it creates what's called the magnetopause. And that's what you're looking at here, or a magnetosphere. That's what I should say there. But, guys, this is magnetic pressure here on the bottom. That's all being generated from all that compression and all the highly charged particles that are getting through. Okay, remember, this is a two-dimensional model. But everything that's in our reality is three-dimensional. So it's hard to be able to give people a visual, right? And this is where I go back to what Tamitha Skov has shown people, and it really clicked with me when she did it. I didn't have the understanding until she said what she said and did what she did over there on her show years ago. You could pretend Earth is sitting inside a slinky. It's that simple. That's how our magnetic field is. Okay? That's why things come in on our poles. Each little coil of the slinky is a magnetic field. field line. Okay? Now, yes, they get moved, they could get compressed and everything else. So it's just a great analogy, and I know I keep going back to that, but I do think it helps people that are new, that have no idea what space weather is, get some sort of an idea. And that's what you're seeing here. Okay? So this is magnetic pressure, and everybody understands pressure, right? So when that happens, and guess what, guys? That's also part of the reason we get a seismic uptick. We will see an uptick in house fires, electrical issues globally. That's happening right now as we speak. Also, I want to point out, because people ask me, what's this do to us? Well, the biggest thing it can do to us is just knock our power out if it's strong enough. Is that happening right now? No. There's probably regional or maybe local small things happening. We get transformer fires. There's an uptick on that. Guys, this affects things. And I know that sometimes we can't see it. It's because you don't know, and myself also, we didn't know where to go to look to see if those things were actually being affected. And they are. It's in the data, it's in the reporting, it's there. Okay? Heidi, did you donate 5 more? Thank you. Appreciate you. If you did, I appreciate you anyway, but I think you did. Sorry, I haven't been watching the chat. So, yeah. Let me go back down here. I didn't have my chat updated. Sorry about that, guys. Why are they saying something cracked? Other weather sun observers? They're saying that what cracked, just so you understand. And I know you. I think you live in a different country, because I remember having a conversation with you. What they're talking about is a crack in the magnetic field. We get cracks that open up in our magnetic field. They can happen at any time, believe it or not. There's times that we'll get like, I don't know, maybe the phi angle flips, or something like that. And you probably don't even know what that is either. The phi angle is this, okay? The phi angle is the actual polarity of the solar wind itself. So when it flips polarity, it'll sometimes yank on us, and it can put us into a brief geomagnetic storm. Why does it do that? Well, because it opens up a crack in our magnetic field, and things just filter in. This is why I take you guys here. This is the Aurora oval right now. If you want to see Aurora, get there. Oh, there you go. Cayeno's Kid, red Aurora in northwest Florida. Guys, that's low latitude. Low latitude. So you're talking down here in Florida. Okay, so cracks open up. That's just what happens when we get hit. That's what they're talking about. Thank you for the super chat, by the way. Very cool. I'm not going to be able to show... I might be able to show you some I got in my email. Might or might not. Not sure yet, guys. But, yeah. We will take a look at it if I can get to it later on. But, anyway, this is one of the main indicators I can show you when we're talking about Aurora, that we are getting hit with geomagnetism. Because this reacts immediately. What causes Aurora? Remember the slinky analogy, right? So all the stuff comes in on our poles easier. That's the point of least resistance for everything. Because negative's drawn to positive, positive drawn to negative magnetically. So depending on what kind of magnetics is going on, it gets drawn into the south and the north pole. Let me go. Is that? I know I had the Aurora. I guess I didn't. Well, let me pull that up. But as I'm pulling that up, check this out. This right here is your culprit. Okay, I'm going to slow this down. This is from the same satellite that I showed you guys that Comet on. But this is actually zoomed in version. So the Comet's not in its view. So that's why you don't see it here. But this is the X-flare and the massive CME that blasted off this thing. Moving more than 2 million miles per hour, I have to add. That's why it got here so quick. Okay, the sun's 93 million miles away. If it was moving at 1 million miles per hour, it would take it 93 hours to get here, right? Well, this thing got here in under a day. You do the math. Okay? So, as I'm speaking about that, I do want to pull up the Aurora dashboard here. Okay? Guys, this is what they're forecasting. So, and we're already exceeding this. Okay? That's a KP of 8. But right now, we are popping in and out of KP 9, 10, and 11. Now, I want to point this out too. This chart only goes up to 9. Okay? Yes, it can get higher. And that's why I'm pointing it out. Over here on the German website, we definitely see it. Okay? So, we got up to, what is that, 10.3? We only need a 9 for a G5. So, this is G5 level. Even here, it's showing a 9 negative. If that said positive, they would consider that a G5. So, just so you know. Also, our radiation storm is pretty much gone for the mere fact that this thing hit. It hit and it grabbed all those protons that were in our D region. Here. See next to the poles? It grabbed them all and flushed them out. If I was to show you this from earlier, well, it might even show you here at the beginning. Yep, you see how far down that is? That's the megahertz. I'm not going to get into detail on that. But watch as we progress here. See how it's kind of backing off? That's what's happening there. We got hit, and this CME is actually grabbing those protons, which is radiation, and helping us by flushing it out the back. So, that's what's happening. But, yeah. So, okay. So, we got this going on here. Now, they may change this, and they should. And they do when they get more data in. But this right here is the forecast, today and tomorrow night. This is the actual conditions. Check this out. That's North Pole. That's South Pole. Okay? Yes, our friends down south get it too, guys. All right? Shout out to my Aussies. Shout out to my South Americans over here. And shout out to my people over in South Africa. I got people that watch me on all those continents. So I wish I could give you guys a better, more accurate, and more in-depth for your location. But we simply don't have the models for that. I wish we did. I really do. I try to give you guys a global update here, and that's why I keep things more global than regional or local. And that's why. Because, you know, trying to pinpoint things down locally would just be too difficult. It's almost impossible to do that for the whole world. Okay, so here is what we call SDO. This satellite's in geosynchronistic orbit. In other words, it stays over the same part of our planet at all times. Okay, it does a figure 8 pattern, but it stays over basically over the western United States, and it does a figure 8 pattern down towards South America over the ocean. Okay, but it stays there at all times. It orbits our planet at the same speed as we rotate around our axis, which is 15 degrees an hour. So it keeps it in the same place. And they do that so they can relay the data back in real time, back to White Sands. If that was to be on the dark side of the planet sometimes, well, the opposite side of the planet as where they're trying to get the information back to, then we would have blackout times. And we do get small blackout times where we get eclipses. Now that right there, guys, is a calibration roll of the satellite. We see that often. Sometimes when the satellite gets hit, or we get these geomagnetic storms, they have to steer these things back into place. Why do they have to do that? Well, because we now have more geomagnetism hanging around. And it's like this, guys. If you're standing in a sandbox, right? You're barefooted and you're walking across the sandbox. And then somebody comes over with a 5-gallon bucket of sand and dumps it right over the top of your feet. And then you try to walk again. What happens? Huh? It slows you down, right? Well, the reason why it slows you down is because it's adding more sand, more particles. So it's adding more. So it causes drag. Hey, Shaper Girl, good to see you. Yeah, Shaper Girl, that is a very valid question, and we do see that. She says, why am I not seeing northern lights up here in northern, did you say Utah? I think that's where you're from anyway. Yeah, it's a good question. And again, guys, it comes down to where the cracks are opened up the most. Also, it could be timing. There could be, and I don't know exactly where you're at, but there could be light contamination. Even if you're out in the country, if you live anywhere near big cities, it becomes very hard to see Aurora. And I don't know exactly where you're at, Schaefer Girl, but that's a great question. It truly is. I've had that question for a long time. Why do we see it here and not here? And we're on the same latitude line, right? So, it's a good question. I don't have a really good answer for you. Other than I would say that, when you get a crack open up, or even a bigger crack, that's kind of how it happens. And it is timing. So, yeah, and you might see it a little bit later as we get deeper into the night. Now, I will also say this. I do know one thing here, and I can show it to you. Our oval here, okay, this oval is moving. So you may not be quite there yet, is what I'm saying. If you look at this, if I grab this and I roll it back, that's where we're at right now. So if you were to take this and rotate it forward, it would be over top of you right there. So maybe in a few hours, maybe. I don't know if that's the right answer for you or not, but maybe that could be it. I don't know. Leah's in here. She knows quite a bit about Aurora. She might have a better answer for you than me. I would like to know that myself, though. But I think that's probably why. Again, that's a great question. It truly is. Very good question. Because, guys, listen. That's one of the first things we're going to see when we're getting hit. Okay? That's one of the first that we can go straight to an indicator. And be like, hey, look at that, But anyway, that's the X-flare that hit us. Okay? Then the X-flare happened with the X-ray. The X-flare hit with a, I believe, I can't remember exactly how hard that was. It was like an X 1.8. It wasn't like a massive, massive X-flare. What's hitting us now is the CME that was produced with it. Okay, like I said, the Carrington event, 1859. That's when they noticed that we see a flare and a CME. So the effects from the flare are here in 8 minutes, almost instantly. It's moving at the speed of light. So keep that in mind too. When you look up at the sun, you're seeing what that sun looked like 8 minutes ago. So yeah. Anyhow, now, so what can this, I get these questions all the time, and it's valid stuff. What does this stuff do? And I kind of already went over what these things can do to us. And I would highly suggest you guys get over and watch Ron, Emergency Management Associates. He's always on top of the seismic stuff that's going on. That's one of the things that can happen. And when I say seismic uptick, I'm not just talking about earthquakes. We see volcanoes, we see just geysers, whole lot of different things happen. And we do see a clear uptick in the data, guys. It is not a question whether that happens or not. It's just it's a factual thing that you can look at. So just know that. This isn't something somebody's just pulling out of their booty and like, hey, look at this. No, that's not it. So these are the geomagnetic storm scales. We can also see radiation storm scales. Basically, this is going to tell you what you can expect during certain conditions. Now, this is over at NOAA, Space Weather Prediction Center. You guys can go over there and scroll down on any page, and you're going to see this. These are all the links to almost everything I just showed you. You guys can access these models just as easy as I can. This stuff is all paid for by our tax dollars, so this is free to use. That's why we get to use it. But you can go to dashboards. I already showed you the Aurora. The one I show you guys the most is the Space Weather Enthusiast dashboard, which is this one, right? because it's got pretty much everything we need to know for space weather, at least the critical data points and models. Now, again, they're forecasting, guys. Look, I haven't seen them forecast this like this in a long time. I mean, we're talking G4 for 12 hours, then G3, and it slowly tapers down. So, yeah, we're going to be in this storming for a couple days. It's not going to just like hit and run. That's not how this one's working. Okay? Now, again, guys, I think our radiation storm is pretty much gone. That's pretty much done. And a lot to this. See, you got, and what I said earlier, this thing hit and it drug all those protons out, right? How can I show that to you? Look, we jumped up to a G4 right here. Look when the radiation storm started to fade. Right when that hit. Okay, it's all about the timing. Look at your models. That's all you got to do. Time it out. If it works out time-wise like there, that's what's happening. So, yeah. Now, let's see here. I'm just want to try to make sure that I'm getting everything to you here. I don't want to forget anything. Now, again, guys, this is the Discover data. This is very boring to look at. But what's not so boring is this. Always remember, probably the most critical data point we can look at, again, is the BZ. I harp on this all the time. -6 is what we need, right? To really couple to a CME. Look where that's at. That's -46. Very seldom have I ever seen it go that far south. I'm serious. Even back in May, earlier this year, I don't think it got that far. So what I'm saying is, the conditions right now are really, really ripe to bring that stuff in. And that's why we're at where we're at. The density isn't extreme. We're looking at about, 10 to 16. That, 4 is normal, but density can be 40, and we don't even get a geomagnetic storm out of it. That happens sometimes because the BZ, if the BZ's in the positive, it actually deflects things. It helps us deflect things. Our magnetic positioning is, you take two positive polarity magnets and try to push them together. They're pushing away from each other. Same thing's happening here. If you got a positive against a positive, they're not going to want to come together. It's going to deflect it. So that's why you need the proper magnetic polarity, and that's why this data point is so important, okay? But the speed here is the difference, okay? The speed in the BZ, obviously, because I already went over that, but the speed went straight to 800. 800 kilometers per second. Now, what that means is for every 400 kilometers per second, what are we looking at? We're looking at about 1,000,000 miles per hour. And that's just rule of thumb. Now, you can get a calculator. They're all over the internet, and you can do it exact. But for what I do, rule of thumb here, okay, we're at 800. That's at least 2,000,000 miles per hour. So it's probably a little more than that, is what I'm trying to say. So if you do the math on that, you'll start to understand why this thing got here so fast. And obviously, the faster it's moving, typically, the harder it hits. Okay? Now also, when the density's real high, sometimes that'll slow things down. Same thing, the feet in the sandbox, dump more sand on there, right? It's harder to move that sand. Same thing's happening. Okay? So the faster speed typically means a little bit lower density. And that's really significantly true when we're talking about just like a normal coronal hole stream. And I showed you guys that coronal hole earlier. Right here. That's the surface of the sun. The surface of the sun is colder than the atmosphere. The corona of the sun, which is the atmosphere of the sun, is actually hotter than the surface. This is not a hole in the sun. This is a hole in the corona. A hole in the atmosphere. You're looking at the surface. Why is it black? Because it's colder than everything else around it. That's one of the things we can look at to show you that, hey, the surface of the sun is actually colder than the atmosphere. They sent the Parker SP probe out there. Oh gosh, it's been a while now. It's the satellite that they, it was big time news when it happened, as well as it should be. This satellite actually got into the atmosphere of the sun. It kissed the sun is how the words that they used. So it got in there and was able to collect some data. It's still hanging out there. It's not in the sun's atmosphere, obviously, because it wouldn't be here anymore if it hung out in there too long. But yeah, so that's that. Now, again, guys, can I see the future? No. Do I know how long this is going to last? No. I can only go off of the models and the data and go off of what I actually have seen before and just kind of go off of my opinion there. I do think this is going to last quite some time. I 100% agree with at least the length of this solar storm. Okay? This could last longer. It's not going to pan out exactly like this, guys. It never does. I mean, we got to understand what we're looking at here. The sun's 93 million miles away. And I just showed you all the variables that go into it. So, you know, to expect something to be exact is just not an expectation that we should have. They give themselves plus or minus 8 hours on the timing of this anyway. And they would consider that a correct forecast. So 8 hours before or 8 hours after. Now, as far as the intensity, I'm not sure what kind of plus or minus they give themselves there. I've not seen a number on that, but yeah. Okay, now, that's pretty much all of it, guys. I don't have much more. I mean, that's the news today, guys. It truly is. And this is going to be like this for a couple days. Now, again, even Dr. Tony Phillips, G5 Extreme. That's as strong as it gets. Oh, I forgot to read the... Yeah, okay. I kind of got sidetracked there. Sorry. What can we expect during a G4 or 5? Possible widespread voltage control problems. Okay? Right here. Some protective systems will mistakenly trip out. What does that mean? Well, we all know what a GFCI is, right? A ground fault circuit interrupter. Most codes where you live now. Well, thank you, Jeremy. I appreciate that. Most building codes now require GFCIs. When they're talking about that voltage control problems and protective systems, that's one thing that we use in our houses to protect ourselves. Your GFCI and your wall switch could trip out. It truly could. It's no joke. So, but it's mistakenly tripping out. It's not really having an issue. It just trips out because of what's happening here geomagnetically. Good to see you, Renee. Appreciate you. But also may experience spacecraft. This is spacecraft operations. This is G4, not G5. Okay. Tracking problems, corrections may be needed for orientation problems. In other words, guys, all this stuff is hitting our atmosphere, right? It's adding density. It's adding more particles, highly charged particles. So it's adding drag to the atmosphere where these satellites are at. What happens in drag, like I explained earlier? It slows things down. The satellites get slowed down during these things. Okay? What that does is, you got to understand a little bit about orbital mechanics. Satellites are not up there just sitting there in the perfect spot, right? They're in a continuous state of falling. Now, I know some people might have a hard time wrapping your head around that. But because of that, you got to understand they're talking about the center of our planet. Not the crust. Okay? Not the surface. That's where they're measuring things from. The center of our planet. So it's falling in that direction. So basically what happens is they use that. It's like, you guys ever seen the movie Armageddon, right? And Billy Bob Thornton uses the terminology, the Roadrunner slingshot move or something like that, where they had to go out to the moon and use the moon's gravity to increase their speed as they slingshot around it, right? To get to the back of that asteroid. Same thing is kind of happening to our satellites at all times. It's just we know where that position is, and we're able to keep it there. Now, satellites are in areas for specific reasons all over the place, right? But most of them are in closely the same area. Now, when you add drag from extra particles, they have to steer them back into place. So that's what they're saying here. They may need to have to steer these satellites. Guys, we could lose satellites. We do all the time during these storms. They get damaged. We get surface charging. That's one of the biggest things. Also, something that's pertinent to right now. We've got the big catastrophe down in Florida, right? These geomagnetic storms cause havoc with radio propagation. First responders, a lot of them still use ham radio, that frequency. If we're having these storms, it can slow down first responders because that's what dispatch is using to contact people. Now, most of them are using GPS now also, so obviously things are a little bit better, but what I'm trying to say is this can actually have that kind of an issue. Okay? Now, a G5, widespread voltage control problems. Okay? They're not saying fake ones either. They're saying real stuff here. Protective systems. Sometimes the satellites will shut themselves down into safe mode. Because if you shut something down and the electricity's not going through it, when you get hit with something like that, it's not going to affect it. Okay? It's kind of like EMP Shield, that product. It shuts things off really, really quick for you, and it keeps it safe. That's the whole purpose of it. So if electricity's not running through it, things that would mess with electricity can't mess with it. It's that simple. Transformers may experience damage. We see transformers damaged every time we get G5 storms. Go look at the data. That's just all I'm going to say. I mean, yeah. So anyway, again, same thing here, guys. Plus our health. Cardiac departments in hospitals and big-time surgeons and all that stuff, they now look at this before they do big-time surgeries or even small surgeries nowadays. I'll have to take the time to go and do a show one of these days on what this can do to us biologically and how it can affect us. My grandpa had a pacemaker growing up. There's a reason why they told him to stay away from the microwave when it was running. You want to know why? It's because of the magnets that are in it. What are we talking about here? Geomagnetic storm. You see how you can kind of start drawing and connecting the dots here? This is what happens. We understand this now. This will affect our human resonance, which is the vibrational frequency that bounces around between our surface and the top of our ionosphere. We need 7.83 hertz, which is what's normal. If it gets outside of that, in lower or higher, it can do what happens is they used to call this space sickness. They have to pump that actual frequency into the ISS, into anything that's out in space that is not inside our ionosphere, because it affects us mentally. That people legitimately go crazy. Okay, so same thing is the truth for people that work underground. That frequency is not bouncing around underground. So they do it for coal miners and other people that work any kind of mining. That's a fact, guys. Now, I know we all heard about birds going into, coal mining and stuff like that. That's there mainly for like hitting gas pockets. That bird will die real quick and they know they need to get out of there. But that's old time stuff. That they might still use it. I don't know. But the fact of the matter is the human resonance is not there. The human resonance, one of the main easiest things to point to show you what that can do, it can give you tendinitis. Yeah, it will be a good. Hey, thank you for being a member for so long, Schaefer Girl. Appreciate you. Guys, anybody that is a member, you guys get a free super chat once a month. Please use it. Please. Really. Seriously. It would be awesome if you guys would just light that up with that. Seriously, it really would. Please use it. It's one of the perks you get. So, anyway. You're trying to use it? Okay. Miss V, you cracked me up. Anyway, let me say this. The Schumann resonance, when it's off, it can give us tinnitus. In other words, ringing in your ears. So, yeah. That happens. Happens all the time. So, yeah. There you go, Renee. Thank you. There's another one. Member for 5 months, baby. Guys, you'll notice that for each, like 1, 3, 1 and 3, and then the next badge color is 6 months. 6 months or more, you get you'll have a blue Kool-Aid face. And Renee's almost there. So, yeah. Everybody use that. So, yeah. I tell you, Miss V, yeah, 100%. A lot of people do. I do too. I sleep with a fan. If I shut my fan off, I can't sleep because my ears ring. There you go, Daniel. Good to see you, brother. Good to see you, man. Thanks for the super chat there. Love it. Thanks for being a member. 100%. Yeah. Hey, cul-de-sac. Trish in the house. But yeah, also guys, ringing in your, yep, check that. Yeah, for sure. Heart palpitations. Guys, it's one of those things. I mean, I think a lot of us can relate. I really, truly do. It's one of the things that we can all relate to, is simple stuff like that we just would not in any way, shape, or form sit here and say, hey, my ears are ringing. What's the sun doing today? You know what I mean? Ain't no normal person walking around that don't know this yet going to say that. That's what I'm trying to say. That's why I try to, go there sometimes and try to explain to people. How can the sun affect us that way? Well, it can change the Schumann resonance. And then the Schumann resonance will give us tinnitus. That's how it works sometimes. Not always. But yeah. Yeah. 100% Z Cali. 100%. They'll tell you that. The tinnitus. Yeah. Kind of probably did sound like that. But no, I mean, honestly, guys, their surgeons and their doctors are going to tell them what you just said. They're going to tell them, take it easy, please, during all this stuff. They really will. People that are flying, they make them, they can't fly during certain situations. This radiation storm, if you were to fly high latitude, that's one of the things that can happen during a proton radiation storm, is you get an extra dose of radiation. You're getting an X-ray up there. They don't like pregnant women flying during those conditions, and they will not allow their cabin crew and the flight crew to fly a certain amount of hours during those conditions. So if you're flying high altitude and high latitude, latitude means closer to the poles. Now, I've never been able to report on a solar storm that's a 4. Okay? An S4. I never have. Never seen it. This is one of the strongest radiation storms I've ever seen. It's long duration, and we were bouncing in and out of S3, S2. During the last G5 storm we had back in May, we got to G3 for just a second. But yeah. Hey, that's a good link there. Thank you, miss, for doing that. Guys, check out that link she just posted in there. Mark, can you see the auroras tonight? I might be able to. I was just talking to my wife about that. Let's go over here to that real quick. Right here, guys. Check it out. This is where you can expect to see aurora. Now, I'm going to tell you this too. You need a list of symptoms? Okay. I might be able to help you with that. Seriously. And you know what, though, Shaper Gray? You might be able just to Google it. I don't know. I haven't really, looked for, a specific list of symptoms that you can get. Thank you for the super chat, by the way. Let me just highlight that. Thank you. And guys, yeah, I mean, and I know a lot of the symptoms that can happen. But yeah. And one thing before we get off here, guys, I would like to ask for prayers for everybody. Also, my dad's going through some things right now. And, you know, yeah. Yeah, so just pray, okay? For everybody. Miss is going through things. Trinity, our friend Trinity, is going through some stuff too. And, I mean, a lot of us are, okay? And that's why I don't try to, like, just single on myself. I don't want to talk about my health or my whole, you know, issue here where I'm at and everything. Because, hey, listen, we get enough negativity everywhere, right? I'm not going to focus on that, especially when I'm here. So just know that that's not what my channel is going to be about. But I do not have pride in the sense that I will ask for prayers when prayers are needed. And I do that unapologetically. Prayers, love, you know, send us good thoughts, whatever your thing is. That's what I'm saying. Hey, Ripper, good to see you, my brother. Hey, Jammer, what's crack-a-lackin'? Tomorrow, baby. Heck yeah. So, guys, let's get some ones in the chat. I mean, just like that sucker up for me, would you? And then follow through with it. Okay? Don't just say it. Do it. I do. I pray every day for everybody. I truly do. I might use it as a blanket prayer. Like, hey, guys, everybody I've talked to today, all their, you know, all that stuff, please help. That kind of thing. And that's okay. We can't expect us all to remember everybody and every ailment, right? But, yeah. What'd you say there, Jammer, bud? I don't want to miss your... Yep. I'm going to see Mr. Axe. Good to see you, brother. Guys, you guys need to get in there and go check out his channel. Guys, just go check out my awesome channel list. Please. Please. It's the only channel list I have. Go check it out. That's who I go watch most of the time. Axe is on that channel, on that list. So, yeah. Yeah. So, do that. I wish I could just take the time and shout everybody out that you know, everything. Good to see you, Marilyn. Thank you for that. You know, it's too much. I can't do it everybody every time. So that's why I've done that. Also, like over on Marfugal, they have a website too. They put all their friends on a list over there, so people know where to go. I kind of do that with my awesome channel list. Not the same, but you know, guys, I'm not kidding about Axe. You guys are really missing out on a good time if you guys don't go up there and check Axe out. And I say up there. You don't know why I say up there? He lives in Canada. That's why I say up there. I bet he gets that a lot. Hey, Deep Quake, thank you, brother. I appreciate you, man. 100%. Oh, by the way, get over and check out Matthew Shipley, too. Again, he's in my awesome channel list. He runs a 24-hour live feed, showing all the sun and solar weather and anything that affects that kind of thing. One of the best graphics in the world, in my opinion. Hey, Alicia, good to see you. Tiger's Eyes in here. See your thing. Good to see you guys. But anybody that gets much love to all. That's right, buddy. Thanks, man. Appreciate you, brother, for that. That's one of those free super chats, guys. Use them. Use them. Hey, Kim. All right, guys. I'm going to go ahead and pop off here. I would tell everybody, please, 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 go try to see some Aurora tonight if you got good weather. Oh, yeah, you will, Rip. I'm already getting reports out of Florida, bud. So it's definitely getting down south. So here, let me show you this. This is the oval, Rip. Check this out. Watch. I'll run it back for you here. Okay? That's where it's at right now. If you were to, like, point to its most intense spot, I would say you have a couple hours, or maybe even right now, dude. If you were able to get out of the city, you might be seeing them now. I'm getting, like I said, I got a report while I was live in the chat. They're seeing red Aurora in Florida. So, but yeah, so that's just what it is. But check it out, brother, for real. I hope you're doing good, man. I hope you're feeling better. I know you're feeling bad there for a while. But me too, you know. What I'm saying, man? Well, it seems like me and you, we always have about the same type of stuff going on. I was fighting cellulitis. I still am, actually. But at the same time, I don't dwell on it. And, you know, I think me and Rip kind of are cut from the same cloth, man. We don't like to dwell on those kinds of things. We just like, you know, we'll mention it when we want prayers or what have you, and then we leave it alone after that. That's just how I do things. I've seen him do the same. Hey, Stephanie, good to see you. By the way, guys, listen, any of my mods that are listening to me, I need you guys to email me, but give me your screen name. I'm setting up a room for you guys. I haven't made the room live yet, but I want to make sure that I got who I want in there. But my moderators, any moderator, I want all my moderators there as long as they can. But if you email me, tell me your screen name on YouTube, because sometimes I won't recognize it. That way I can send you an invitation to the Telegram room, and you guys can talk behind the scenes. So, I can't see what you said there, man. Let's see here. I posted a pic from North Carolina. I just got on. Okay, cool. Cool. Yeah. Hey, Tiger's Eye, thank you for that. Appreciate that. How many months? 4 months. Awesome. I do. Hey, IG, good to see you. Yes, I did, IG, for sure. I did. Thank you. Anybody that's already done that, just disregard what I said. I know who's already got them to me and everything. I got you, girl, for real. But let me say this too. Anybody that goes out and looks for Aurora, if you can't see them, pull your phone up. Stick your phone in the air, and you might not even be able to see it through your viewfinder or whatever. But take a picture or a small video, and then look at it. If I had done that back in May, I would have seen Aurora where I'm at, and I haven't. So yeah, that's just what I'll say. Oh, did she? Heather Joy got to see him already? That's awesome. Aurora, there you go. Tracy's talking about Aurora in Alabama. You guys notice where all this Aurora is coming from right now? It's kind of from here. So I would say, Schaefer Girl, you're on tap to see him pretty quick, and then Rip would be after. This is not going to go away. This is going to be an all-night thing. And then even tomorrow night. So you guys, if you got good enough weather and can get away from the lights, you guys should be able to see something, at least up here. Because, like I said, we're getting reports in Alabama, Florida. I've seen something from Arizona and Texas. You know, we're going to see them in Mexico, those kinds of things. What you got here? Northern Illinois, whole sky's red. That's cool. The lighting, sweet. Sweet. Jennifer, what's up? You see him in Pennsylvania too? Yeah, there you go. See you guys? Okay, gotcha, Aaron. Thank you, guys. Also, and I ain't saying this because Aaron said this. It just kind of struck my memory. If you guys do send me Aurora and you want me to show it, I need you guys to tell me, say, hey, you have my permission to show that. I don't want to show a picture that you guys don't want me to, number one. Number two, it just protects my channel. People make their living off of Aurora photography. And if I don't have permission, like in an email or something like that, I won't show it for that reason. So just so you know. Yep, Aaliyah. Sweet. All right, guys, I am going to go ahead and pop off. I don't want to drag this out just because we got stuff going on here. But, again, if something intensifies, or even if it doesn't, if I feel like I need to do an update for you guys before tomorrow night's show, I'll be here, okay? Most likely, I might do one in the morning just to give you guys an update. during these kinds of storms, I like to do that because people start to wonder where we're at and what's going on. So, especially, guys, look. Let's look at the HP one more time here. We're not coming off of a KP of 8 right now. HP of 8. Everything we're seeing is above 8. 8 is G4 level. So 9 is G5. Anything above 9 is G5 level. They don't have a G6 or a G7, just so you know. That's usually a question I get. But we're hanging right around there, and we're hanging real close to G5 level on a consistent basis right now. And I already explained why we're going that high. I had a small inclination we would do this. I think I even said it during my stream last night, or even, last night and today. So yeah. So I highly encourage you guys to go back and check that out too. But this Comet thing is cool. I think it's really, really cool. It did not blow the tail off the Comet, by the way, just so you know. There was a chance that it could have, and it did not. Also, the sun is still erupting, guys. Just because we're getting geomagnetic activity right now doesn't mean the sun went right back to sleep. It's definitely still firing, and we still have sunspots facing us that I forgot to show you. Right here. This sunspot here is the one that fired the big one at us. That's hitting us now. But as you can see, we got all this stuff too. Earth kind of sits just to the south of the equator of the sun. Kind of right here. This sunspot was right here when it fired. That's why we're getting what we got. Okay? That's why it looks like this. That's what's hitting us right now. It's called a halo eruption. Anytime you see a full halo around this occulter disk, it's called a halo eruption. And this disk is a physical disk on the camera. A lot of you guys already know that, but if anybody's new, that's what's happening here. They call it a halo eruption when they see energy coming out around this disk. Just so you know. But, alright guys, I am going to go ahead and pop off. I'm sure Marf will be going live here. Guys, get over and check out Adam and Dex over on Marfugal News and TV. They did an awesome job last night covering the hurricane. They were on for an extended period of time. Ended up being like 3 hours. They do that during bigger events. But they're there every night. So get over there and check out Marfugal. I will always shout them out. They have helped most of you guys know who they are. So, anyway, guys, God bless. Yahusha saves. And as always, what is it here? What is it here? You can drink this Kool-Aid. What color is it? Anybody know what color it is? It's blue Kool-Aid, because that used to be my name, but my favorite Kool-Aid's red. You know, hey, can't help it. I tried to be red Kool-Aid, but those names were taken when I went and got my name. They wouldn't let me do it. Even regular, just Kool-Aid wasn't even there. So I had to add the blue to it. That's how I ended up being blue Kool-Aid for years. But anyway, God bless. Yahusha saves. And as always, you can drink this Kool-Aid.